Okay, for numbers 2 and 3, we're looking at forming polynomials in expanded form. In other words, the full layout, not the factor form, but just the expanded form. And we have for number 2, now we have 3 zeros, one of which is a non-integer where we have the fraction at -1/2, and then we have, with the other zeros, we have a 0 and 5. Now just in setting up a polynomial, okay, you can see we have f of x is equal to, and we can just say for the initial factored form, we have a -1/2. We can say this can come from at the root. We have the quantity of x plus 1/2, and we have with 0, okay, we have x, and we can say that 5 will stem from x minus 5. And now you can maintain the fraction, but let's say that if you want to avoid having to use fractions, what you can do here is that we have with the first factor, we can just rewrite the 1/2 as 1. If I multiply this first factor by 2, so you can just say that I have 2 times, okay, the quantity of x plus 1/2 times x times the quantity of x minus 5. And we have f of x, okay, 2 over the quantity of x plus 1/2. We're going to have at 2x plus 1. Notice if I set 2x plus 1 equal to 0, I would have 2x equal to -1, and with division by 2, I would still have x at -1/2. And I still have times x and times x minus 5. And if I multiply the factors in order from left to right, so if I have 2x plus 1 multiplied by x, I will have 2x squared plus x, and with x minus 5 waiting to be multiplied. Okay, so I'm going to have, upon distributing, okay, so we have f of x is equal to 2x squared over x. Okay, so I'm going to have at 2x cubed, and then I have the outside product we're going to have at -10 x squared. Inside product we will have at x squared and x times -5. Okay, we have -5x. So one version of a polynomial solution in this case is where we're going to have 2x cubed minus 9x squared minus 5x. Again, not necessarily the only solution, but in terms of integer coefficients, okay, this is the one that will have the smallest number. Now, for what we have for exercise number 3, we're looking at forming a 5th order polynomial. Okay, that's going to consist of 2 zeros, one of which we have at -3, which will consist of a multiplicity value of 2. And we have 0, which will have a multiplicity equal to 3. And if I set up the factored form, so we have with x equal to -3, we can say that this will stem from x plus 3. And we have in terms of multiplicity, okay, now with the multiplicity of 2, this will be in reference to where we have, since -3 has a multiplicity of 2, its corresponding factor representing it is going to be raised to the 2nd power. And we have with 0, okay, we see we have the factor to be at x, and with the multiplicity of 3, we have not just x, but x to the 3rd. And as we look at expanding, so we have with the square of x plus 3, this will be x plus 3 times itself. Again, the easy thing to remember is the square of x and the square of 3, so you have x squared plus 9, but remember, you're going to have outside and inside terms to combine, each of which will be at 3x. So for the square of x plus 3, we're going to have x squared plus 6x plus 9, and multiplied by x to the 3rd. We'll have for this particular end result, okay, we'll come out to x to the 5th. And we have plus 6x to the 4th plus 9x cubed. All right. Now, where we have polynomial division to come in. All right, for number 4, it says to express x cubed minus x squared plus 2x minus 8 as a product of linear factors given that 2 is a 0. All right, and let me mention something here. Now we have with 2 as a 0, we have x is equal to 2, and this will be in reference to the divisor, okay, x minus 2. And if we were to take what we have in terms of line division, again, you'll have x minus 2 is the divisor. And now for the polynomial that we have at x cubed minus x squared plus 2x minus 8, okay, that is going to be the dividend. And if I take what I have in the arrangement and put in terms of synthetic division, okay, so again, x minus 2 has a 0 of 2. And again, 2 is a given 0. And we have in terms of synthetic division, x cubed has a coefficient of 1. Next term is negative x squared. So we have a negative 1 for the coefficient. And we have positive 2x for the coefficient of 2. And we have negative 8. So we do not have any missing degree terms. And with the synthetic division, so if I bring down 1, I have 2 times 1 is 2. Then we have negative 1 plus 2 is positive 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0. Okay. Now, again, so we have with the divisor, okay, we have x minus 2. And for the quotient, okay, now the original one from the top we had in reference to x cubed, but after a round of division, okay, this one at the front is going to be referenced not to x cubed, but x squared. Okay, so we have x squared. The next one is going to be in reference to x, and we have 4 to be the constant. And since 2 is an official 0, we would expect the remainder to be equal to 0. So in terms of writing what we have as a product of linear factors, so we have x cubed minus x squared plus 2x minus 8. And that is going to be equal to, with our factors, okay, and since we can't really factor x squared plus x plus 4 into integer coefficients, we'll just leave this in quadratic terms to have the quantity of x squared plus x plus 4 times the quantity of x minus 2. And we will just let this be our end result. Now, in terms of looking at what we have regarding quotient and remainder, we have with number 5, okay, so we have with the divisor at x plus 1, and we have with the dividend, okay, so we have negative 2x to the 4th. Okay, next term we have a 3x cubed. Okay, after that, now we do not have an x squared term, but I will need a 0 placeholder. And since I do not have a first order x term, we'll use another 0 placeholder. We have minus 3 at the end. So this is what I have in the long division setup. And just translating what I have in terms of synthetic division. Okay, so I have with x plus 1. Again, the 0 is going to be at negative 1. And so taking this over to the realm of synthetic division. So we have with the coefficients, okay, so I have negative 2, positive 3. I have 0 for x squared, 0 for x, Also we have negative 3 to close out. So bring down negative 2. So have negative 1 times negative 2 is a positive 2. And we have, in this case, we have 3 plus 2 is 5. Negative 1 times 5 is negative 5. 0 plus negative 5 is minus 5. Negative 1 times negative 5 is a positive 5. 0 plus 5 is 5. Negative 1 times 5 is negative 5. And adding together, okay, so come out to negative 8. All right, so in terms of what we have with the quotient, now again, the original negative 2 in the setup was in reference to x to the fourth. But as we bring down the result after the round of synthetic division, so the negative 2 at the front, this is going to be in reference to negative 2x cubed. And we'll have plus 5x squared. The negative 5 that follows will be in reference to negative 5x. And then we have with a constant at the end, okay, we have it 5. And for the remainder, okay, the value will be at negative 8. Okay, so the quotient, again, we had this third order polynomial, and the remainder we have at minus 8. Now, in the case of 6, okay, we have the divisor at x minus 5. The dividend, okay, we're going to have missing terms. Dividend we have at 7x to the third. And we're missing a squared term. And we have minus 4x. And you want your dividend to close out with a constant. Okay, so we have 0 as the placeholder. And again, we have with x minus 5 as the divisor. If I put this in terms of synthetic division, you can use log or synthetic division, but very likely synthetic division will save you quite a few steps in the process. Okay, so we have, again, just in the setup. Okay, so I have 5 is the 0 for the coefficients of the dividend. So I have 7 for x cubed, 0 for the missing x squared term. Negative 4 for what we have in first degree in x, and I have 0, and we have in the process. Okay, so bringing down 7, 5 times 7 is 35, 0 plus 35 is 35, 5 times 35 is going to be 175, and negative 4 plus 175 is going to be 171, 5 times 171 is 855, and we have the remainder to be at 855. So it's going to follow that what we have here is that the quotient, this will be at 7x squared plus 35x plus 171. And again, we have with the remainder, we have at 855.